Alright, so continuing with this page, talking about the different height requirements for rides. So, in between videos, I went ahead and added these as well. So, initially I had put the climathon, which shows I took the height of 53 inches, and I substituted into the inequality for the climathon, and it gave me a true statement. And then I also substituted it in for the inequalities for the other two rides. And this says 53 is greater than or equal to 55. That's not true. And here it says 53 is greater than or equal to 58, which once again is not true. 53 is not larger or equal to 58. So once again, that shows that this is the only solution that is true. So that's why she can ride the climathon, because we plugged it in to the inequality and it worked. But here, when we plugged it into their inequalities, 53 did not work, so she could not ride these rides. So now, down below, I rewrote all of the rides inequalities just to keep them more accessible, and now we can go ahead and answer 4 and 5. So, Jada is 56 inches tall. Which rides can she go on? Alright, so let's check the high bounce. So once again, if you are going to check if someone is tall enough, we should be able to take their value and plug it into the inequality and solve it. So, high bounce is greater than or equal to 55 and less than or equal to 72. So, if I put 56 in for her height, so here's the high bounce, and that is greater than or equal to 55. It is greater than, so it works. And it should also work for the other part, because remember, this was like a range of values in between 55 and 72. And that is true as well. So she can go on the high bounce. Okay. And once again, this is something that, this is like a good way of showing it. I want you guys to get in the habit of substituting in values for inequalities. However, you could also just, if you just thought about it, so we knew the high bounce, you had to be in between 55 and 72 inches tall. I think most of us could just get that 56 is in between those two numbers. And real quick, I want to take a pause here and mention the term solutions. We've talked about them last unit when we were learning about variables. Okay, because we're still working with variables, but now we're working on them with inequalities. And so a solution is a value, so a number substituted in for a variable. So we got to remember that substitution means replacing a variable with a number. So it's a value substituted in for a variable that makes an equation true. So right here, we can see that when I substituted in this value to these equations, it made them both true. So her height, 56 inches, is a solution for the high bounce. Now let's try the climathon. So, once again, I'll call this one CT, and its height is less than 60. Her height is 56, less than 60, and that is a true statement. So she can also ride the climathon. And now the twirlicoaster, call that TC, and that's H is greater than or equal to 58. Is 56 greater than or equal to 58? No. So that is not a solution. Not a solution. So, to write your answer as a sentence, Jada can ride the high bounce and the climathon, but not the twirlicoaster. Alright? Corinne is 60 inches tall. Which rides can she go on? Why don't you pause the video here and try it yourself. Alright, so at this point, hopefully you completed 5 independently. I went ahead and paused the video and just completed it to save time so you didn't have to watch me writing. Once again, I just substituted in crane's height into each of the different inequalities for the different rides. And so in the high bounce, 60 is greater than or equal to 55 and less than or equal to 72. So whenever you can plug in a value and it makes that equation or inequality true, that's called a solution, and that means it works. It worked for the roller coaster. It did not work for the climathon. Because remember, if there's that line underneath the inequality that's greater than or equal to, if there's no line, that's just less than or greater than. 60 is not less than 60. 60 is equal to 60. So 60 is technically too tall for the climathon. So she can only ride the high bounce and roller coaster. Important to note. All right, and now for number 6. We've got two inequalities. H is greater than 64 and less than 75. I made this little number line to kind of represent all of the possible values. And we need to find 3 different solutions for these inequalities. So go ahead and pause this video and see which ones you can come up with. All right, so I'm going to do 65, 73, and 68. I can clearly see that all 3 of these are between these 3 values, so they should all be solutions. And if I check them, 65 is greater than 64, that works. And 65 is less than 75, that works. 68 is greater than 64, that's true. 68 is less than 75, that's true. 73 is greater than 64. And 73 is less than 75. So these are my 3 solutions that would work for those 2 inequalities. Alright, so we have seen things like this before. I want to continue practicing these. So once again, we are working on writing inequalities based on a number line. So remember, the colored line with the arrow and the point, these all represent x, okay? So where you see the big, thick colored line, that is representing all possible values for x. So let's look at the first one. X starts on 1 and it goes to the left. So remember, left is less. As numbers count to the left, they start going down. So as we go deeper and deeper into that negative territory, the numbers are just getting smaller and smaller. So my answer for this one is x is less than 1. Okay, and so remember here, x cannot be 1. That's why it's an open circle. X can be 0.99999, so extremely close to 1, but cannot be 1. It can only be or equal to if that dot is colored in. So go ahead and complete this page, and then you can resume the video to check your work. Alright, so here are your answers. So x is greater than -8. So once again, it starts at -8 and goes to the right. X is less than or equal to 7. It starts at 7 and goes, the numbers get smaller. Left is less. And once again, this one's or equal to, because since that dot is colored in, that means 7 would also be an okay value. X is greater than or equal to 0. Once again, you can see all my values for x are counting up. And then x is greater than 5. We start at 5 and then begin counting up. So, what are some possible values for x on the first number line? Well, looking here, remember everything that's on this line, x could be. So x could be, looks like -1. I see -5. I see -10. I know that that arrow goes on forever. So it could be -1245, right? It could be any number that goes down. It could be -7 and 8500ths, because that's a full line. So, you know, all rational numbers, fractions and decimals are included there as well. So all of these would be acceptable answers, because once again, if we substituted them in, Is negative 7 and 85/100ths less than 1? It is. So that would be a solution. That would be a possible value. Okay, possible values for the second number line. Looks like it's got to be greater than negative 8. So negative 7 and 85/100ths would work again here. What else is greater than negative 8? Negative 1. All positive numbers. So 10. 20,000. So once again, it goes on for forever. So anything greater than negative 8 would be true there. I could plug that in for x and it would work. And for the third number line, once again, so the third number line starts the or equal to type problems for these two because it's colored in. So 7 would work, and anything less than it. So 6 would work, negative 10 would work, negative 5/10 would work. Anything less than 7. Alright, and that brings us to our lesson summary. So please make sure to read this over and copy down your big ideas. So 1, an arrow on a number line or graph means it goes on in that direction for forever. So really, you know, for any inequality, in theory, there's infinite values, because if it goes to the right, you could just keep on counting up. Also, the open circle is just less than or greater than, or the closed circle is less than or equal to, or greater than or equal to. And also, any value substituted in for a variable and make something true is called a solution. All right, so make sure you copy that all down and get started on your practice problems.